Okay, welcome, section 4.3. And this time we're going to do a simulation around the caffeine experiment and whether it increases your heart rate or not. So here is a table from another class's data of 10 students that had a drink with caffeine and 10 students that had no caffeine in their drink. They both received a drink so that minimized the effect of the placebo. And here is the final pulse rate minus the initial. So for this person, their final heart rate was 8 beats faster per minute than before they drank the drink. Okay, so again, positive numbers mean your final rate was higher. A negative number means that your final heart rate was lower than when you drank, before you drank the drink. And we want to find the difference in the mean pulse rate for the groups. So what that simply means is we're going to be looking at the caffeine minus the no caffeine. So 3.2 minus 2 is a 1.2 difference, 1.2 difference in hearts beats per minute. Are we convinced? Possibly, but a difference of 1.2 beats per minute is not very big. Other possible explanations for the difference: it could be that the caffeine did cause the change. It could be that it was just coincidence and the caffeine group had a larger change. This is a pretty small sample, so really we would like to have a bigger sample if possible. Okay, so if we want to do a simulation of this, what we're going to assume is that it was coincidence. And we're going to try and use the exact same values and see how often do we get a difference with the caffeine group being higher or lower. So we're looking, is it big enough to be convincing? And typically we consider 5% as the threshold for convincing. So here's what we're going to do. Each group should have a pack of of these cut up index cards. On each side there is a number. It's not on each side. On one side there is a number. Mix up these cards, and then what you're going to do is we're going to deal them into 2 stacks. So, 1, 2. And let's go ahead and finish dealing these. Okay, we finished dealing them out. And now what we're going to do is I'm going to just designate the stack on the left for my caffeinated group. The stack on the right is for the non-caffeinated, or the decaf drinks. I'm going to turn them over. I'm just going to fill in these numbers. So this person had a change of 5 beats per minute. This one had 8. And we're just going to continue filling in our chart like this. So 4, -1, 1, 0, -1, 2, 5, and 4. And again, this was just a mixed up random sample because we're assuming that it was just coincidence. Then I'm going to take the second set of cards and fill in the bottom row. So 4, -2, 5, 1, 1, 0, 3, 6, 4, and 3. And then we're going to, when we flip over, we're going to find the mean of each group. So my mean of caffeine and my mean of no caffeine. Let me calculate that right now. Okay, and I've calculated that. We'll go on to the second page now. So for my group, my caffeinated group, the mean change was 2.7. And again, yours is going to be different, minus the decaf or no caffeine group, which was 2.5. So my difference was just 0.2 beats. Okay, and now I'm going to add my 0.2, the difference, to the dot plot. So my dot would be approximately right there. And you're going to want to do this for everyone in the class. So you will be putting on your paper dots from everyone in the class, and if you're later in the day, the classes before you as well. And we want to go over what does each dot represent. It represents the mean differences from one trial if caffeine had no effect whatsoever. So if it was purely coincidence, the difference in heartbeats. Okay, and then we want to look at what percentage of the dots are greater than or equal, so they can equal the difference that we found initially of 1.2. So what I would have to do is come over here and I'll put in my line at 1.2 I should make a note there, that's 1.2. And I want to count all the dots over here. So dots that are to the right or on the line, I'm going to count. Then I want to interpret this. So again, we want to make sure we're counting the dots at 1.2. And if I want to find the percentage that are greater than or equal, I count all the dots over here and divide by the total number of dots. Okay, so I'm trying to find that difference there. Okay, let's see what happens. Okay, so once you've divided the total number of the dots to the right or on the line by the total number of dots and get your percentage, the way we would interpret this is we would say, assuming that caffeine has no effect on your heart rate, there is a blank percentage or probability of getting a difference of 1.2 or more purely by chance. Because again, remember that was our assumption. And to know if it's significant or not, if our percentage is less than or equal to 5%, then we say, yes, that is pretty unlikely to happen on its own. So it's probably due to the caffeine in the drink. And that would be called statistically significant. However, if our percentage, when we just did it randomly, we had more than 5% of ours have a change of heart rate less than 1.2, then we would say, no, it's not that unlikely. And that first reading of 1.2 as a mean difference could have just been a coincidence. And that is not statistically significant. So if we turn over now and fill in our notes, our big ideas here, sampling variability. Important thing to remember is that samples are going to be different. You're taking samples from a population, and each time you will have a different sample. So different samples will yield different estimates. Larger samples produce more accurate estimates. So when you have a choice, we want to have a bigger sample size. We will have a margin of error, and this creates an interval of plausible values. And our margin of error is simply what you consider acceptable error. So we get our estimate from our sample, and then we will add or subtract some margin of error. The other idea that's important is statistically significant. When the results from a study are too unusual to have occurred purely by chance, and typically 5% is the threshold. For our example, we did a simulation using our index cards, and we used the same difference in heart rate and just randomly put some as with caffeine and some without, which is what you would expect if there was no effect of caffeine. And you would put your sample results on a dot plot, draw the line at the threshold you're checking, count up the number of dots that are greater than or equal to that, divided by the total number. And if that proportion of dots is less than or equal to 5%, so 0.05, then your results were statistically significant. If it's greater than 5%, it is not statistically significant. And again, that is based on our assumption that caffeine had no effect on your heart rate. Okay, go on to take a look at the second video, and you have homework over section 4.3.